Okay, so hello aspirants, I hope all of you are doing perfectly well. हम लोग सेंटर ऑफ मास एंड कोलिशंस के ऊपर बहुत सारे क्वेश्चन सॉल्व कर रहे हैं, तो वैसा ये क्वेश्चन फिर से मैं आप लोगों के सामने लेके आया हूँ। जो क्वेश्चन फिलहाल स्क्रीन पे है, जरा क्वेश्चन को देखिए और इस क्वेश्चन को पढ़िए क्या बोला गया है, और फिर हम लोग इस क्वेश्चन को सॉल्व करते हैं। ठीक है, क्या बोला गया है भाई क्वेश्चन में कहा गया है कि अ बुलेट ऑफ मास 10 ग्राम मूविंग हॉरिजॉन्टली एट स्पीड ऑफ 50√7 मीटर पर सेकेंड स्ट्राइक्स a block of mass 490 gram kept on a frictionless track as shown in the figure. The bullet remains inside the block and the system proceeds towards the semicircular track of radius 0.2 meter. Very good. Okay, where the block strikes the horizontal part after leaving the semicircular track. Where the block will strike the horizontal part after leaving the semicircular track. ठीक है, जैसे ही semicircular track को छोड़ेगा ये block इस हॉरिजॉन्टल पार्ट को फिर से कहां पे ये टच करेगा, ये यहां से पूछा गया है। बड़ा ही सवाल, अच्छा सा सवाल है। थोड़ा सा हम लोग को बेहतर होगा अगर हम लोग थोड़ा सा, अच्छा बेसिकली इट्स अ परफेक्टली इनलास्टिक कोलिजन। ठीक है, बुलेट और ब्लॉक वाला जो सिस्टम है वहां पे वो ना परफेक्टली इनलास्टिक कोलिजन, क्योंकि दोनों मास अटैच हो जाते हैं आफ्टर द मोशन। दैट्स अ परफेक्टली इनलास्टिक कोलिजन। तो इस कोलिजन में हम लोग बात कर सकते हैं कि क्या सिनेरियो हो रहा है यहाँ पे। So it's a perfectly inelastic collision. Let's talk about this. Let's talk about this. Let's talk about this. तो हम लोग यहाँ पे लिख सकते हैं कि since the bullet remains embedded, embedded, embedded inside the block after collision. So it's perfectly inelastic. Inelastic collision. So I can just simply write down that mass of the bullet, capital M, multiplied by velocity of the bullet plus mass of the block, mass of the bullet multiplied by velocity of the bullet, which is minus v, suppose, or minus v or u, plus mass of the block multiplied by its velocity, which was initially at rest. Should be equals to both mass, then move together, the small m plus capital M, they move with the same velocity, suppose minus v, because they're moving on the leftward direction. Minus u I cap, I can write minus u I cap minus v I cap. So tell me, what's the value of v? It's basically the magnitude of v, that's what I'm asking. Magnitude of v is equals to small m divided by small m plus capital M, small m divided by small m plus capital M into u, because this negative sign and this negative sign cancels out. So this is your v. So this is the v with which they both will move together. You know the mass of the bullet, you know the mass of this. So I think we can find out, we can figure out this value. Can we not? Can we figure out this value, what I'm getting here? M into small u divided by small m plus capital M. ये वाला फिगर आउट करना आसान है, बताओ क्या होगा? I think it's easy to figure out this value. कैसे फिगर आउट करेंगे? सर जी एम का वैल्यू पुट करो, अच्छा, एम ग्राम में है, ये भी ग्राम में है ना, ये मीटर पर सेकंड में है। ठीक है चलो कोई नहीं, ग्राम ग्राम कैंसिल हो जाएगा, बट तुम लोग अगर चाहो तो लिख सकते हो। स्मॉल एम का वैल्यू लिख दो। स्मॉल एम तुम्हारा है, ग्राम को केजी में कन्वर्ट करोगे तो 0.01 केजी। कैपिटल एम तुम्हारा हो जाएगा 0.49 केजी। तो 0.5 केजी। तो ऊपर में तुम्हारा आ रहा है 0.01 मल्टीप्लाइड बाई 50√7 डिवाइडेड बाई 0.01 प्लस 0.49. So that's basically your 0.5, मतलब 5/10, जो 10 ऊपर जाएगा तो नीचे 5 से काटूंगा तो 10√7, 10 ऊपर गया है तो 10 डिवाइडेड दिस तो 1/100, so it's √7, right? 0.5 means 5/10, ऊपर में you have 1/100, so 100 is half, 5/10 cancel out, so it's √7. Yes. So v is basically your √7. The velocity with which this entire mass will move along this side is v. That I have got. I've got the value of v. Acha, one more thing I want to know. With what velocity it will just leave the track? Could you tell? See, there is no potential, kinetic energy loss or anywhere because there is no friction. The track is entirely frictionless. We can say this, the track is entirely frictionless. So basically, suppose it's leaving it here, where it will leave, the block will leave this. So mg will act in the downward direction, exactly in the downward direction, and that will be actually equals to your, suppose if with any velocity it's leaving, that will be actually equals to your the centripetal acceleration, centripetal force. So from there you can definitely find out what the centripetal force is. Apart from that, I can tell you the kinetic energy conservation. That is again a very important stuff. The kinetic energy conservation, or the conservation of entire mechanical energy, is again a very important stuff. So velocity at the point B and velocity at the point, okay. ठीक है चलो, फिलहाल तो हम लोग थोड़ा दिमाग लगाते हैं। काइनेटिक एनर्जी का कंजर्वेशन अगर कर रहा हूं तो what can I say? अच्छा एक सेकेंड, एक पार्टिकल वर्टिकल सर्कल को कब कंप्लीट करता है भाई? यहां तक तब जाता है जब उसका वेलोसिटी रूट ओवर ऑफ 5 g r से कम होता है, 5g into r, राइट? यहाँ पे g इज योर दिस, रूट ओवर ऑफ 10 से कम. सो a particle goes to the reach to the top of a vertical circle, reach to the top of a vertical circle . if the velocity at the bottommost point is greater than or equals to बड़ा है equals to root over of 5g into r. So that means should be greater than g is your 10. Here the radius of this vertical circle is 0.2, that is 2 by 10. That's your 5. 10 will cancel, root over of 10. So it should be greater than root over of 10 because r equals to 0.2. But here the velocity is 7. It will leave the vertical circle if velocity at the bottommost point is greater than root over of 3gr less than root over of 5gr. Okay, r is 0.2, so 10 cancels out. 6, so it should be greater than root over of 6 but less than root over of 10. We have v equal to root 7 which satisfies this relation. So let the block will leave the circle at this point. The block will leave the circle at this point. Move like this. Let the block will leave the circle at this point. So I can show you the vertical circle. This is my vertical circle. So suppose here it will reach till here, it will reach, and then from here with some velocity which is tangent to this, it will leave. Okay, now from here I can draw the mg's and all those sort of things. So that's my mg. I can resolve mg in two components, one along this direction, another along this direction. Okay, one along this direction, another along this direction. So these two forces we can take into consideration. The first thing is, see, if I tell you that this angle is theta, so this is mg cos theta, this will be mg sin theta. Okay, I need to know with what angle with the vertical it's actually leaving the circle. With what angle with the vertical it's leaving the circle. That's what I want to know. With what angle with the vertical it's actually leaving the circle. That's what I want to know. In that case, suppose it's leaving the circle at some angle theta. Okay, suppose this angle is theta. Let's say this angle is theta. If this angle is theta, then I can say just because these two are 90 degree, this two are 90 degree, this is 90 minus theta. Again, this two are 90 degree, so this angle has to be equal to theta. This angle has to be equal to theta. So this is theta, so this is mg cos theta, this is mg sin theta. Mg cos theta is actually working in that direction. mg cos theta is the initial velocity, what I'm getting here. I hope all of you have understood this question, right? देखो सिनेरियो ऐसा, ये तुम्हारा वर्टिकल सर्कल है, इस पॉइंट से अगर वो छूट रहा है मोशन तो ये उसका सेंटर है, ये तुम्हारा mg है, मान लो हॉरिजॉन्टल के साथ थीटा एंगल कर रहा है, ये वेलोसिटी थीटा एंगल कर रहा है, ये वेलोसिटी, this is some force acting along this direction and this is acting along this direction. इसको हम दो कॉमेडी सॉल्व कर सकते हैं mg को. But if this is theta, this is the tangent, this is the radius, so of course this is 90 degree. कोई भी एक सर्कल का tangent और radius हमेशा 90 एंगल में होता है. So this is 90 degree, so this angle is theta, so this is 90 minus theta. Again this and this are 90 degree, so this is 90 minus this, so this one has to be equal to theta. If this one is your theta, so of course this one will be mg cos theta, this one will be your mg sin theta. So I can just write down mg cos theta is actually your mv square by r. So mg cos theta is your mv square by r. If this angle is theta, then this is also theta. So this is your mg cos theta, this is mg sin theta. Now I can write two equations. One is, let at point P the block leaves the circle. Therefore m vp square by radius should be equals to mg cos theta, because whenever it's leaving the surface, basically there is no sort of normal reaction that's acting in the downward direction. It's just rotating in the vertical circle, and this mg is actually giving you the inward force. So that's all I'm trying to say. Okay, mg cos theta will be actually equal to this. Now if I know this, then tell me mg cos theta is basically your mvp square by r. And secondly, there is another thing which I can do the conservation between the potential energy and the kinetic energy. That thing is also very important. तो जब ये ऊंचाई पे चढ़ेगा तो कितना इसका होगा पोटेंशियल एनर्जी, वो भी हमें देखना है. तो जब नीचे था, अगेन हाफ m into जब हम यहाँ पे ब्लॉक की बात कर रहे हैं तो हम लोग को पूरा का पूरा चीजें लेना है, सिर्फ स्मॉल m लेने से काम नहीं बनेगा. m is our m1 plus m2. m is our m1 plus m2, स्मॉल m प्लस कैपिटल m, जिसको हम लोग लिख सकते हैं m डैश्ड. ओके फाइन, चलो m डैश नाम देते हैं स्मॉल m प्लस कैपिटल m को. तो m डैश साथ में मूव करें, vp स्क्वायर बाय r, दिस इज m डैश g cos theta, अगेन हाफ m डैश वेलोसिटी स्क्वायर v square plus potential energy of the ground is 0 is actually equals to half m dashed. जिस velocity से वो सर्कल को लीव कर रहा है, that velocity is basically equal to which one? vp square plus उसका जो potential energy होगा, that can be written as like how this distance. सर्कल को बड़ा करके ना दिखाओ तो ये समझ में नहीं आएगा. ये सिनेरियो है, यहाँ पे छोड़ रहा है ना ऐसा, तो यहां से ये तो सेंटर हुआ. दिस इज योर r. ओके फाइन, दिस इज r, सो दिस इज I know that this angle is your theta. This is theta, so इसके साथ ये 90 degree, so this is 90 minus theta. अगर ये 90 minus theta है, this is 90, so this is your theta. ये 90 minus theta, तो ये theta होगा. Because this angle is your theta, right? So इसके साथ ये तुम्हारा ये tangent है, ये तुम्हारा radius है, तो of course 90 degree, तो ये theta है, तो ये 90 minus theta होगा, ये 90 minus theta है, तो ये 90 degree होगा. So ये theta हो जाएगा. So this is r cos theta. जो साइड पे है r cos theta plus r plus r cos theta है. तो m dashed g r plus r cos theta. Done. M dash g r plus r cos theta. That's all I can say. Now this thing is done. M dash can be cancelled out. So simply you can write v square by 2 is equal to, or simply v square is equal to 2 to half of cancel कर दो, m dash by 2 cancel कर दो, vp square plus 2g r into 1 plus cos theta. From here you can tell me what's your vp square. M dash cancel out, gr cos theta, gr cos theta. So v square equal to gr cos theta plus 2gr into 1 plus cos theta. Tell me 2gr cos theta plus gr cos theta, that is 3gr cos theta plus 2gr. So if you take common gr, fine. So v square is actually equal to 7. 3g into r is 0.2, 0.2 into g is 2, so 6 cos theta. R is 0.2. 0.2 into 10, that is 2 into 4 plus 4. 7 minus 4 is 3. So cos theta is equals to 3 by 6, that is half. Sin 30 half means cos 60 equals to half. So theta equal to 60 degree. With 60 degree with this horizontal, this ball is actually leaving the surface. Ball is leaving the surface. That's a very important stuff. With 60 degree with the horizontal, ball is leaving the surface. So basically I have a projectile that is actually has made its journey by making an angle 60 degree with the horizontal, and of course I can tell you the velocity, which is very simple to find out. Therefore Vp square can be written as, from here Vp square is gr cos theta 10 into 0.2 into half. So it's 10 into half, that is 5, 5 into 0.2, that's 1. So Vp equals to 1 meter per second. That's very kind, that's very good. So if I know Vp equals to 1 meter per second and it's at an angle of theta equals to 60 degree from the ground, then I think I can tell you at what distance from here it will strike the ground over here. So यही पूछा था ना ग्राउंड को. Okay, where will the block strike the horizontal part after leaving the semicircular track? Okay. हमें पहले तो ये ढूंढना है कि लाइक कितना, एक सेकेंड, कितना पोर्शन उसे लगेगा वर्टिकल डिस्टेंस को कवर करने में. सो वर्टिकल डिस्टेंस आई थिंक आई एम वेरी मच श्योर ऑफ. सो it has made its journey with a velocity of 1 meter per second at an angle of 60 degree with the horizontal. Now it will go up it will come down, and then it will come down. How long would it take? So पहले तो हमें निकालने की ऊपर जाने में कितना टाइम लगेगा, फिर सेम टाइम उसे नीचे आने में लगेगा, प्लस उसका टाइम लगेगा जब वो एकदम से नीचे आ रहा है, मतलब जब जमीन को हीट कर रहे हैं. दैट्स द लास्ट पार्ट. That's the last part. Okay, now I want to know what's the time for reaching the ground, right? What's the time for reaching the ground? ठीक है. Can I just know that what's this distance? यहाँ से उसे यहाँ जाना है. It will hit the ground from here. This is the ground. ये डिस्टेंस कितना ऊंचाई पे है, उसका ये डिस्टेंस कितना था, r प्लस, this was the radius, r cos theta, r plus r cos theta, r plus r cos theta, right? This distance is your r plus r cos theta. Good. So but that it has to travel along the negative direction. This is equals to t plus half a t square. ठीक है. फाइन. पहले अगर ये ऊपर से ऐसे करके जाएगा, बेसिकली प्रोजेक्टाइल मोशन में टाइम ऑफ फ्लाइट कितना होता है. अगर मान लो ये एक प्रोजेक्टाइल है, यहां से जा रहा है, दिस इज यू, दिस इज थीटा, दिस इज यू साइन थीटा, यू कॉस थीटा. सो ऊपर जाने में 0 इज इक्वल्स टू यू साइन थीटा माइनस जी इंटू टी. तो t इज इक्वल्स टू यू साइन थीटा बाई जी. जितना ऊपर जाने तो उतना ही टाइम, टू यू साइन थीटा बाई जी इज द प्रोजेक्टाइल ऊपर से नीचे आने में, टू यू साइन थीटा. तो ये तुम्हारा टाइम पहले से लग रहा है. प्लस जब यहाँ पे आया तब इसका 0 वेलोसिटी था, यहाँ से नीचे जाएगा, जाके वहां पे ग्राउंड को टच करेगा, जो है तुम्हारा कितना डिस्टेंस दूरी पे, एस इज इक्वल्स टू यू टी प्लस हाफ जी टी स्क्वायर. बट इनिशियल वेलोसिटी यहाँ पे 0 है, तो सिंपली 2s बाई जी का रूट ओवर, दैट्स द टाइम, रूट ओवर ऑफ 2s बाई जी. तो दैट्स ऑल. सो टाइम टू हिट द ग्राउंड, time to hit the ground, t is actually equals to projectile motion का time, that is 2u sin theta by g, theta by g plus root over of 2 into s divided by g. You tell me this thing, 60, right? So 2 into 1 into sine 60 by g मतलब 10 plus root over of 2 into g मतलब 10. S is r plus r cos theta, r into 1 plus cos theta. Sine 60 means root 3 by 2. Root 3 by 2, 2 to cancel, root 3 by 10. Here I have 1 plus cos theta, 2 by 10, r equals to 0.2 means 2 by 10. So 4 by 10, 4 by 100 I'm having here. 4 by 100. Okay, r is equals to 0.2. 0.2 means the radius is 0.2 means 2 by 10, right? 2 into 2, so 4 by 10. 4 by 10 is 4 by 100. 4 by 100. 1 plus cos theta. Cos theta is basically your half here. Cos theta is basically your half here. 2r into 1 plus cos theta. Cos theta is basically your half here. So half plus 1 is 3 by 2. 2. So basically I'm having 3 into 2 is 6 by 10, 6 by 100, to 0.06 root over. So all I'm getting from here is root 3 by 10 just hang on for a moment. Root 6 root over of 0.06, 0.06, that is 0.2449, and root 3 by 10, root 3 divided by 10 is 0.1732 plus 0.2449. So I'm getting 0.4181. 4181, 0.4181, 0.4181. That's the time. In this time period, how much distance will travel along the horizontal direction? The velocity along the horizontal direction is v cos theta. So therefore, horizontal distance traveled is actually equal to this velocity. This is the time v horizontal, which is actually your u cos theta into t. So 1 into half into 0.4181. So 0.209, which is 0.21 approximately. 0.21 is the distance from the horizontal at which it will strike the ground. That's the answer. So total distance it will cover in that period of time is basically 0.22 or 0.21, whatever you write. That's what we have seen. What they have mentioned here, where the block will strike the horizontal part after leaving the semicircular track. So after leaving the semicircular track, it will travel a farther distance of 0.21. It will travel a further distance of 0.21. That's all. Okay. Fine. Tell me if there is anything you need to understand. अगर किसी भी जगह पे समझ में ना आया हो तो बता सकते हो. यहाँ पे मास को इनिशियली इस जगह पे हम लोगों ने वेलोसिटी u माना था, तो इस वेलोसिटी को हम लोग u ना मान के vp बोलना ज्यादा सही रहेगा. vp, इसको अगर vp बोलेंगे तो यहाँ पे 2 vp sin theta by g, 2s by this. vp is your 1, तो यहाँ पे भी vp cos theta बोलना बेहतर रहेगा. vp cos theta into t. Good. तब जाके 0.21 आ रहा है. That's the final answer of this question. So it was a good question actually. बहुत ही बढ़िया सा सवाल था ये सवाल. काफी अच्छा क्वेश्चन था. Like this sort of question you can always you can try. You can always expect for your exams. ऐसे questions बहुत अच्छे होते हैं. So mostly we can see this sort of questions in our later on classes also. एक और एक क्वेश्चन है जहाँ पे एक इंसान सोया हुआ है. जरा वो क्वेश्चन को देखना. तो हाँ, यहाँ पे ये वाला क्वेश्चन है. The track shown in the figure is frictionless. No, B, okay. A block B of mass 2 meter. A block B of mass 2 meter is lying at rest. And block B is at rest, and the block A of mass and the block A of mass m is pushed along the track with some speed. The collision between A and B is perfectly elastic. With what velocity should the block A be started to get that sleeping man awakened? So it has to reach here. It has to reach here. That's what they're trying to say. It has to reach here. Good. Okay. So whenever there is a perfectly elastic collision, we can always conserve the momentum, right? And we can see that with what velocity this sort of things are happening. They have had a perfectly elastic collision, okay? Block B of mass 2m is lying at rest and the block A of mass m is pushed along the track with some speed. Collision between A and B are perfectly elastic. Okay. With what velocity should the block A be started to get the sleeping man awakened? Hmm. So I know the velocity. Okay, it's a perfect Laplace solution, so I can definitely conserve the linear momentum and the kinetic energy. Can I not? Without any second thought, I can conserve the linear momentum and the kinetic energy. Suppose velocity of UA, UB, VA, VB. Mass of A, UA plus mass of B, UB plus is equals to linear momentum conservation is equals to mass of A, VA plus mass of B, VB. I don't know what's the velocities of these two. I'm taking all along the rightward direction, all velocities along the rightward direction. Okay, VB is basically going along this direction, having a velocity of the rightward direction, so I can get VA as well. But here UB is equal to 0, but UA, mass of A is equals to what? The block of mass 2m. Because rest a block of mass m is pushed along the track. So this one has a mass m. So m into UA plus 0 is equals to, this one has a mass of m, this one has a mass of 2m. So m into VA plus 2m into VB. So all the m's are getting cancelled out. So you can say UA is equals to VA plus 2 VB. Again, from kinetic energy conservation, or rather, it's a perfectly elastic collision, right? It's a perfectly elastic collision. So V2 minus V1 or VB minus VA by UA minus UB should be equals to, in a perfectly elastic collision, what do I get? It is actually equals to 1. Good. So what is UB initially? 0. So it's UA. And what's VA? Okay, VB minus VA is equals to UA, because I know that initially the velocity of this block is 0. Okay, all I have taken along the positive x-axis direction. ठीक है, velocity of separation by velocity of approach. Good. Now from this, I can just equate these two terms, can I not? And I can just add these two things. So 2UA is VB minus VA. Just add these two equations, what you will get? If you add these two equations, you're going to get 2UA is equals to VA cancels out 3VB. So 2 by 3 UA. VB is 2 by 3 UA. VB is 2 by 3 UA. And what's your VA then? 2 by 3 UA minus VA. So 2 by 3 UA minus UA. 2 by 3 UA minus UA. 2 by 3 UA minus UA, that's 2 by 3 minus 1. So minus 1 by 3 UA. VA minus 1 by 3 UA. So it is actually moving along the negative x direction. Cities were assumed along positive x-axis. So now I get V is equals to minus 1 by 3 UA. That means it's along the negative x-axis. VB is along the positive x-axis and a velocity of 2 by 3 UA. So with this velocity's goal, it reaches here. With what velocity should the block A be started? So that to get the sleeping man awakened. So it has to reach this point, buddy. So if it reaches this point, at this point it has a zero potential energy, but here, suppose its kinetic energy will be zero, but potential energy will be mgh. I can say. So now I can mention that if block B reaches to the head of the man, then conservation of mechanical energy gives, here it is, kinetic energy is half mvb square plus potential energy 0 is equals to their kinetic energy 0 plus potential energy is mgh, mb g into h. From here I can write down, you see, half mass of this block B is 2m, right? Half into 2m into, what's your VB square? VB square is basically 4 by 9 US square. 2m into, MB cancels out, but still G into H. Just have a look, 2m cancels out, 2 से 4 को cancel किया तो 2 by 9 US square is cancels out, and this is 2 by 9 US square, that's G into H, that's 10 into H. Good. So 9GH by 2 का root over, UA is 9GH. by 2 का root over, 9GH by 2 का root over. But the fact is यहाँ पे H का value बोला नहीं गया है. Did they mention the value of H? No, they did not. So I must get 9gh by 2 का root over. Okay. I think this was right? M cancels out. This is half into the VB square. VB square is basically 4 by 9 UA square. That's 2 by 9 UA is here. MB cancels out G into H. G is here, H is here. G is 10. Okay. Just leave the G and H like this. 9 by 2, it's 4.5. That's what I'm getting. Okay, let's have a look over here again. Mass of MA, mass of UA plus mass of A, mass of AB is equals to MAVA plus MBVB. Now, mass of MA is equals to M. Here, MA it's M, MB it's 2M. This is VA, which is VA, VB, which is VB. I don't know about VA, VB, but I know about UA. So M cancels out. So UA is equals to VA plus 2VB. And again, I know that V2 minus V1 by U1 minus U2 is equals to 1. That's for the perfectly elastic collision. So VB minus VA by U1 minus UB equals to 1. So this is 0. So it's UA here. UA is V minus VA. Do one thing, add these two things. 2UA is basically, if you add these two things, you're going to get VA cancels out, but 3VB. So 2 by 3 UA is your VB. 2 by 3 UA is your VB. 2 by 3 UA is your VB. VB is 2 by 3 UA. That's what I was needed to. Now, if this is half MV square and it's reaching here, half MV square is equals to MGH. MM cancels out, V equals to root over 2GH. So that should be also equals to your root over of 2GH. Right? So here I must get into 3 by 2 UAH. So if it's entering here 9 by 4, so I'm going to get 9 by 2 GH. I'm going to get 9 by 2 GH. So it's 4.5 or 3 by root 2 GH. 4.5 GH root over, if G is 10, so it's 45 H ka root over. That's all I'm getting for this question. That's all I'm getting from this equation. ठीक है, चलो इस क्लास को यहाँ तक ही रखते हैं. We will again continue on the next class. For now, I'm just taking a bye from here. If you have any questions, any doubts, please let us know in the comment section below. And of course, जो भी बच्चे CSIR दिसंबर 2024 के लिए प्रिपरेशन कर रहे हो उनके लिए मैं बता दूं कि बूस्टर कोर्स का प्राइस फिलहाल बहुत ही कम है. बूस्टर कोर्स में जो भी चीजें इंक्लूड किया गया है उसमें there are lots of things. Corresponding, like, I mean, we have that one important thing which is for CSIR booster or all this sort of stuff, where most of the PYQs will be done on the booster class. So जो भी बच्चे PYQs revision के लिए सोच रहे, they can do it. अच्छा, I was not checking the comments, and right now I can see there is a student called Quantum I, and he is saying, sir, ये questions interesting है, but NET के लिए नहीं है. Actually, तुम्हें पता नहीं है, there are lots of students who are actually requesting for TI for exam, upcoming TI for exam. In this upcoming TI for exam, तुम अगर TI for के previous year के questions को देखोगे तो वहां पे बहुत सारे questions न्यूटोनियन मैकेनिक्स के ऊपर आते हैं. तो मोस्टली TI में जो न्यूटोनियन मैकेनिक्स के ऊपर क्वेश्चंस आते हैं उसका रिवीजन करा रहे थे हम लोग फिलहाल के लास्ट फ्यू क्लासेस में. अगर तुम नोटिस किए होंगे तो इन दोज लेक्चर्स वी हैव कवर्ड the rotational dynamics, the collisions, the center of mass things, and a little bit of motion in the vertical circle. तो ये सब चीजों से क्वेश्चंस आ सकते हैं TIFR में। तो ऐसा नहीं है कि हमारे पास जो भी क्राउड है, जो भी बच्चे हैं, वो सारे के सारे CSIR नेट ही दे रहे हैं। बहुत सारे ऐसे भी स्टूडेंट हैं जो लोग जेस्ट के लिए प्रिपरेशन कर रहे हैं, जो लोग TIFR के लिए प्रिपरेशन कर रहे हैं, जो लोग गेट के लिए प्रिपरेशन कर रहे हैं, जो लोग CSIR नेट के लिए प्रिपरेशन कर रहे हैं। अगर तुम CSIR नेट के लिए प्रिपरेशन करो तो मोस्टली न्यूटोनियन मैकेनिक्स से ज्यादा कुछ चीजें आता नहीं है। 2 चैप्टर है जहां से बहुत सारे क्वेश्चंस पूछे जा सकते हैं या जाने की संभावना है। इवन द प्रीवियस वी कैन सी रोटेशनल डायनामिक्स एंड ग्रेविटेशन, ये 2 चैप्टर्स है। इसके अलावा क्वेश्चंस यूजुअली CSIR नेट में कोई भी न्यूटोनियन मैकेनिक्स से पूछा नहीं जाता है। बट अगर तुम TIFR का पेपर खोल के देखोगे तो TIFR के पेपर में बहुत सारे तुम्हें ऐसे क्वेश्चंस मिलेंगे जो बेसिकली न्यूटोनियन मैकेनिक्स के एप्लीकेशंस के ऊपर बने गए क्वेश्चंस हैं। By Newtonian mechanics, I'm talking about the basic classical mechanics, not the Lagrangian, not the Hamiltonian, not the generating functions, not the canonical transformations, not the Gaussian brackets, not the small oscillations. I'm strictly talking about the center of mass, the collisions, the rocket repulsion, the variable mass system motion, the rotational dynamics, the gravitation. I'm talking about this sort of things. तो जो भी बच्चे TIFR के लिए प्रिपरेशन कर रहे हैं, for them this lecture is helpful. Maybe just you are not doing the preparation for TIFR, तो तुम्हें इतना helpful नहीं लगा। But of course हमारे चैनल में अगर तुम जाके देखोगे तो बहुत सारे ऐसे लेक्चर्स हैं जो CSIR के ऊपर बनाए गए हैं। जैसे कि मान लो अगर तुम्हारा इंटरेस्ट है कंडेंस मैटर फिजिक्स के ऊपर, एक बार प्रीवियस वीडियोस जाके देखो, जहाँ पे पूरा वीडियोस मिलते हैं ना, तुम एक बार YouTube में जाना, वहाँ पे वीडियोस पे क्लिक करना फिजिक्स क्लास के, वहां पे अगर तुम मेरे लेक्चर देखोगे शायद 200 से ज्यादा 250 वीडियोस वहां पे है। वहां पे कंडेंस मैटर के बहुत सारे इंपॉर्टेंट चैप्टर्स है तुम्हारे CSIR के लिए। वहां पे क्लासिकल मैकेनिक्स यूजुअली मैं पढ़ाता नहीं हूँ CSIR के लिए मोस्टली, क्योंकि मैं CSIR के लिए इलेक्ट्रिसिटी मैग्नेटिज्म, तुम्हारा क्वांटम मैकेनिक्स, तुम्हारा स्टैटिस्टिकल मैकेनिक्स एंड एटॉमिक फिजिक्स, ये सब चीजें एंड इलेक्ट्रिसिटी मैग्नेटिज्म मोस्टली ये सब चीजें पढ़ाता हूँ मैं। तो जो भी बच्चे EMT, क्वांटम, स्टैटिस्टिकल, कंडेंस मैटर या एटॉमिक मॉलिक्यूलर फिजिक्स पढ़ रहे हो तो वो लोग वहां पे जाकर वो सारे लेक्चर्स देख सकते हो। आई थिंक दैट विल वेरी मच हेल्पफुल। बट हाँ, हालांकि सबके लिए दिमाग में रख के क्लास लेना पड़ता है, तो कुछ बच्चे अगर रिक्वेस्ट करें कि सर जी हमें TIFR के लिए क्वेश्चन सॉल्व करा दीजिए जो न्यूटोनियन मैकेनिक्स से आते हैं, तो कभी भी उनका बात में सुनना पड़ता है। So I hope the class was helpful. Thank you very much. We will meet in the next session. Bye bye.